From the periodic system of elements, we can see that blue is a metallic element which has 1 until 3 valence electrons, while orange is a semi-metal which has 4 valence electrons. Semi-metals can be called a metal or non-metal, while green is a non-metal which has valence electron 5 until 8. Almost all covalent compounds are formed from non-metal atoms. Two non-metal atoms donate electrons to each other so that one or more pairs of electrons are shared. So, covalent compounds are compounds that are formed due to the sharing of electrons. The elements that make up covalent compounds are elements from the non-metal group. Covalent compounds can be classified based on several aspects, including 1. Based on the number of electron pairs shared, namely single covalent bonds. It means formed from the sharing of one electron pairs. We can see on the example. The example is H2O compounds, where O have atomic number is 8. So the valence electron is 6. So oxygen needs 2 electrons to achieve the stable octet, while hydrogen have atomic number is 1 and valence electron is 1. So for hydrogen is need 1 electron to achieve the stable duplet. So the structure Lewis from H2O and the single covalent bonding we can see in this picture. The second is double covalent bonds. It means formed from the sharing of 2 electron pairs. For the example, we can see on the CO2 compounds. The atomic number of the oxygen is 8, so the electron valence is 6. It means that the oxygen needs 2 electrons to achieve the octet table, while carbon atomic number is 6, so the electron valence is 4. It means that the carbon needs 4 electrons to achieve the octet stable. So the Lewis structure and double covalent bonds from the CO2 compounds we can see at the picture. The third is triple covalent bonds. It means formed from the sharing of the 3 electron pairs. For the example, we can see at the atomic elements such as nitrogen, where the atomic number of the nitrogen is 7 and electron valence is 5. So it needs 2 electrons to achieve the stable octet. So the Lewis structure and triple covalent bonds we can see at the picture. Based on polarity, it can be divided into 2. First, polar covalent compounds occur when there is a difference in electronegativity between the 2 bond atoms, cause electrons to be more attracted to the more electronegative atom. The second is nonpolar covalent compounds. Occur when the 2 bonded atoms have the same or almost the same electronegativity, resulting in a relatively even distribution of electrons.
Okay, the next is about formation process of covalent compound. Covalent bonding usually occurs between non-metallic elements, namely elements that have a relatively large electronegativity. Covalent bonds are formed from the use of shared electron pairs. Carbon atoms and chlorine atoms will be covalent compounds because we know that the C atoms have atomic number is 6 and the chlorine have atomic number is 17. With the electron configuration for C is 2, 4 and the electron configuration for Cl is 2, 8 and 7. Okay, to fulfill the octet rule, the Cl atom also needs 1 electron and the Si atoms lacks 4 electrons more. Okay, please give your attentions. There is the compound of covalent compounds. We know that the compound is Cl4, whereas C have 4 electrons and Cl have 7 electrons. C needs 4 electrons more to get the stability to fulfill the octet rule, and Cl needs 1 more electron to fulfill the octet rule, so that they will be sharing the electron, and then each atom will get the stability. The next is about some of the possibility of covalent bonding. The first is this bond occurs when there is a small difference in the tendency to release or capture electrons, resulting in electron sharing. The second is this type of bonding is common between non-metal atoms. The third is each non-metal atom retains its own electrons and tries to attract electrons from other atoms. The fourth is the force of attraction of each atom to the other valence electron makes the two atoms bond. The fifth is the shared electron pairs are considered to be localized between the two atoms. And the last one is this bonding resulting in spread molecules that reflect the actual chemical formula, or also called molecular formula. Okay, the next is about characteristic of covalent compound. The characteristic is divided into 4. The first is boiling point. We know that water, or H2O, is an example of covalent compound. The covalent bond that bind between hydrogen atoms and oxygen atoms in air molecules are quite strong, while the force that bind between molecules are quite weak. This is what causes liquid air to easily change into water vapor when heated around 100 degrees Celsius. But at this temperature, the covalent bonds in the air molecules, or H2O, are not broken. The second is ease of evaporation. Many of the various materials that we encounter in everyday life are covalent compounds. Most of covalent compounds are in the form of volatile liquids and gases. Volatile covalent compounds molecules often produce a characteristic odor. Perfume and aromatic ingredients are covalent compounds. The third is electrical conductivity. Electrical conductivity, covalent compound in various forms of electricity cannot conduct current. This is because covalent compounds do not contain ions, so the position of the molecules do not change. And the fourth is solubility. Most covalent compounds cannot dissolve in air, but dissolve easily in organic solvents. Organic solvents are carbon compounds, for example gasoline, kerosene, alcohol, and acetone. Ionic compounds cannot dissolve in organic solvents. However, there are several covalent compounds that can dissolve in air because they react with air and form ions. For example, sulfuric acid, when dissolved in air, will form hydrogen ions and sulfide ions.